So question 147, another question about numerical methods, this time to find a root or one of the roots of an equation. So the first graph that I need to draw is the graph of y equals 2 over x. And if I think about the graph of y equals 1 over x, then that looks a bit like that. 2 over x is just going to be a stretch in the y direction by a scale factor of 2. So as far as the sketch is concerned, the basic shape of the graph is going to still look the same. The other graph, y equals 3x minus 2, is a linear graph with a gradient of 3 passing through the y-axis at minus 2. So it's going to look something like that. So if I give you a tidier version of that now, then so those are the two graphs. Now we've got to state the number of roots of the equation 2 over x equals 3x minus 2. Well, that's the graphical equivalent of looking at the number of points of intersection. So how many points of intersection have we got? We've got 2 points of intersection and therefore 2 roots. So now we've got to show that the equation does have a root equal to 1.215 to 3 decimal places. So if we think about the number line, 1.215, the next number up the number line, which is correct to 3 decimal places, is 1.216, and the one before is 1.214. So if we want to prove that it's 1.215 to 3 decimal places, we need to show that it's closer to 1.215 than it is to either of these two numbers. So we have to show that it lies somewhere in this interval, somewhere in that interval, which is between 1.2145 and 1.2155. But first, before doing that, I'm just going to take this equation and rearrange it so that it equals 0, because then I can use the technique of showing a change of sign. So if I say that f of x is 2 over x minus 3x plus 2, then f of 1.2145 is a small positive number, 1.2155 is a small negative number, and because we've got a change of sign and over that interval, 1.2145, 1.2155, the function is continuous, albeit it's not continuous over the whole of its domain, it's continuous over this domain. So that shows that the root lies in the interval 1.2145 to 2155. So therefore it's 1.215 to 3 decimal places. So the last part of the question is to rearrange the equation and use the quadratic formula. So this is the equation here. I've got to try to find a way of rearranging that into a quadratic. And the first thing I'm going to do, clearly a quadratic equation has no denominators, so I'm going to get rid of that denominator by multiplying both sides of this equation by x. So there we go, that's multiplying both sides by x, and then when I take the 2 over to the other side, I get this quadratic equation, and then so that's the showing that it can be rearranged into a quadratic equation. Now if I use the quadratic formula, minus b plus or minus square root of b squared over 4ac, and I get the final answer there, the exact value of the positive root. So that is the answer to the question. It's not plus or minus, and it's not the decimal equivalent. It is 1 plus root 7 over 3 is the answer to that question, because it says the exact value of the positive root. Just for interest, that is approximated by the decimal 1.21525. So that's just confirming what we have done, because that number is correct to correct to three decimal places is 1.215. So there we are.